40. We'll need the boundaries today because we're going to start to do a stormwater reticulation for the data set that we were using last week. And the nodes.4d, I'll have to show you, you'll have to manually drop it into C drive on each of the computers, and just so it will let you get up and running. So if you can go ahead and just save that nodes.4d for me, and let me know when you've got it, and I'll show you where to throw it. Just under the week 5 notes. Right. Everyone got that all right?
Week 5.
Once you've got that nodes.4d, go into your, just copy it, and under C, on your C drive, under Program Files x86, (12D) 10, just drop it in there as a nodes.4d. Okay, you can see along the top there, there's the file path for if you didn't catch it. Program Files x86 12D, and the folder is 10, and just drop it in. There'll already be a nodes.4d in there. Just overwrite it. The last one was created in October last year, I think. Just jump on the Moodle, and under the week 5 notes, there's a folder called notes.4d. You just have to manually put it into your C drive so that the storm function runs today.
So if we've got 12D already open, should we close it down and reopen it again?
Yep. If you're already running 12D, just close the project. It does need to be restarted to recognise the new nodes file.
So we replaced the old one.
Yep. Anyone can get onto the 12D website and download the software, but for it to run on a computer you need a software lock, which in this case is a network license, and a relevant nodes.4d file, and all it does is say that for this license number you've got access to set X amount of modules. Okay? In this case the old one didn't have the storm analysis. Anyone got any trouble finding that? Everyone pretty clear as to where it goes? Right, once you've got it, once you've put that in the relevant folder, just open up the data set from last week, and we'll carry on. What I'll do is I'll recap briefly just on the way I set the global tab and the defaults. You can see under this week 5's notes we've got a whole lot of different models that you can save onto your flash drive or C drive, wherever you want them to, and we'll start to put these in. And tonight we will actually enter in some rainfall data and run some, once we've got some pipe systems in there, we'll start to run some rainwater down it. Has everyone found that all right? Okay, so if you're looking up at the at our projector today, all I've done to the data set from last week is I've read in the XREF boundary 3, I think it was called. The X boundary stage 3. Just using the file IO, I've read that file in, and I now have, I've turned on boundary scheme, and I've now got some boundaries to work to. Right, we're going to use this, obviously, that we will use this to work out where the lots are, so that we can start to locate the pipe network, and also so that we can start to draw up some catchments. So if you just want to read that XREF in, the drawing file, X boundary stage 3. No, it's a DWG file. Yeah, it's under the week 5 notes. Yeah, on Moodle. That's it. It'll prompt you to ask whether you want to save the definition file for the new line type, so it's neither here nor there. We're not going to use it again after tonight. It's just that although it works in between AutoCAD and 12D, sometimes they're not quite compatible, and they just update their properties. So has everyone got something that looks like that? Yeah, it's okay. So you can just close that or minimise it, leave it up, and turn on the model. Just turn on in that plan view. It's called boundary scheme, I think. Yep. You're all right?
How do we include Wi-Fi, power Wi-Fi?
Right. Just on the data sets that I've given you for your assignment, the stuff in the 12DA file you can triangulate and make your design surface. Don't triangulate the AutoCAD data because the boundaries will have 0 reduced levels and your contours will be all over the show. So just for your design surface, just triangulate the stuff in the 12DA file. The stuff in the AutoCAD file, or the DWG file, is the same as this. We're just using it for a reference to see where the lots are and so we can draw our catchments, okay?
When you say triangulate just that file, if you've already loaded up the other ones, just remove them from the model before you...
Yep. So just don't have that drawing stuff turned back. I mean, you can and then go and delete it and edit it, but just to make it life simple for you. That's it.
What we did last week, because I can't find it.
No. I mean, what I'll do is, all I'm going to do is, don't worry about the roading stuff because we covered that last week. All we're going to do is we're going to use those boundaries and the design surface to start to make the. Okay, has everyone at least got their stuff in there? Yep.
Those videos tell me how to do everything. So just look up my email.
So you've got a under moving, you need to download this Right. So what I'll do is we'll just trundle through this morning, this evening. I'm just going to, long day. I'm just going to go through and recap how we set up last week. Okay, I'm going to run through the defaults, the global and the defaults tabs, so that you can get your head around the settings. I will record what I do today, and I will try and get that onto Moodle, so that at least it won't have any. There's no audio to it, but at least you're able to see the tabs I'm clicking on. That's the best we've got at the moment. Okay. So the first thing you need open is a drainage toolbar. If you haven't got it already, you need to come up to the top.
Oh, good stuff. Full screen.
Okay, so the first thing you need is the toolbar. We're going to go View, Toolbars, and make sure you've clicked on the drainage toolbar. And finish. Okay, under our drainage toolbar, we've already quickly just done a rough pipe last week. I'm not going to use that. I'm actually going to provide some reticulation for these new boundaries. So I'm going to come up to my drainage toolbar, and under the fifth from the left, I'll just pull that down so it's clearer for you. Sorry. Our little icon there with the sunshine on it, I'm going to create a drainage string. Okay, in this case I want, apart from the name, the model, the colour and all the other defaults that I set last week, I want to replicate for this one. So rather than fill these boxes out again, I'm going to come down to the bottom here of my Create Drainage String dialog box. I'm going to click Same As. I'm going to pick line 1 from last week and accept. And you see it's populated all the boxes.
What if we didn't have line 1?
Then, if you haven't got line 1 from last week, don't worry, because what I'll do is I'll talk you through these boxes now so you can set them up. And the only thing I'm going to do different than last week is that obviously this is going to be, the names have to be unique, so I'm going to make this line 2. So just to go through the values I entered in last week, just like road centre lines, the model has to be the same for all of these drainage lines. It has to recognise that the naming convention for the model is the same. Otherwise it won't recognise that all these parts of the network are interrelated. So my stormwater lines I stick into a model called SW lines, and wastewater I put into WW lines. Okay, I keep your naming convention simple. So all of our stormwater is going to be in one model, all of our wastewater in another. They have to have a unique name. When it comes to set pit names, if you've got 2 line 1s or 2 line 3s, whatever it is, it won't work. So they're all in stormwater lines and they're all individually named. The colour, I stick to basic council conventions where blue is stormwater, red is wastewater, and that makes it nice and simple to recognise and see what's happening. just as in last week. It gives us two different options here for our flow direction, opposite the string direction, and in the same. Okay, how is the term there? Opposite the string direction, same as string direction. Okay. There's two different ways of thinking about it. A lot of the guys that design the software will start. They will use same as string direction, and quite often their notes will. That's what they'll say. The problem being that what you end up with is a long section like this. When you plot this out under the long section plot, your changes are going to start here. Okay, all the grade information starts at this point. The problem being that, of course, the drain layer is going to build it from the other end. So he's got, there's scope for mistakes to be made because he's constantly trying to interpolate backwards. So what I like to do is keep it opposite the string direction. And I design it the way that it's going to be built. Okay? So mine is going to be 0, 23, 48, whatever they are. Make sense? So I've gone for opposite to string direction. Now I've only got one tin in here, it's just the default data set that I've given you. We need a finished surface to design to, so that what we're going to, as we place these manholes, it's going to adopt that the point on the ground is its lid level. So tin FS obviously is finished surface. If we had a flash design tin, that's the one we'd select. In this case, they're both the same data set. Okay, so we've got to have a tin nominated under finished surface. Clear as mud?
How come it's a different model name to the one in the drawing?
The one in the drawing.
It's called tin ground, that one's just called ground.
Oh, it's just that it's just because it is a tin box that it just it is the same. It's the same tin. So, for instance, if I look in the models to remove box here, you can see that that's what it's actually called. Okay. So once I've got all that information filled out, I'm going to, down the bottom left here, I'm going to click on Create. Alright. It instantly opens up my drainage edit dialog box, and we can get in and start to design. Now I don't have a, this is actually up at Snells Beach, this subdivision. So we're not discharging into a piped reticulation system. We're just going to discharge for the purpose of this exercise. We're just going to run the stormwater out onto the beach, okay? So I'm going to pick an arbitrary place down here. It's just for training purposes, and I'm going to say that this, sorry, I want to go up to Edits, Add Append Manhole. And you see there in the bottom here, it's prompting me for what it wants me to do. I'm going to start to place roughly some manholes. Okay, I'm going to pick an arbitrary position down here that will be my discharge point. And I'm just going to go through and start placing roughly some manholes. Okay, it only has to be rough at this stage. I can go in and move, delete, add manholes to this later if I haven't got it right. There are restrictions here based on the council standard as to how they want you to lay the reticulation out. And the way I've done it here is the way I want it done for your assignment. Obviously anything up in here is in road boundary. Anything in here, this is in private lot. All the drainage for Waitakere or Rodney for that matter, or Manukau, they all require it to be in the front boundary of the private lot. Okay? In fact, it doesn't have to be in the front boundary because sometimes the slope is at the back, but it's within that strip of the private lot. So don't lay it, for your assignment, don't have it running down the road, okay? So all I've done is I've roughly placed some manholes here, and I've got a drainage string that runs up the front of the boundary here. Once I've finished placing them, I just hit escape, and then I'm going to come across to my section over here, and I'm going to click on profile, and I'm just going to have a look at that in section view. So you see here, it's nonsensical what it's put together. All it's done is look at each individual section and do the best it can with the basic defaults. And until we start to edit it, it's going to look a bit bizarre. Yep. You've actually already got. Is this one here for that one? So you go to edit, edits, add a pin, top up, and save. Right, I'll just use that. Now, with the placement, so as I said, there's a few things you've got to think about when you start to place these manholes. The first thing you should be doing is looking at the contours and trying to work out where the lowest point on each of the sections is. What I normally do in the offices, I'll print off the scheme plan with the contours behind it, and I'll just mark a little cross in the corner of where the low points are. Obviously, you cannot, if we have if this is a rough lot layout, a boundary scheme, and this is the highest point of, and this is the lowest point of it. If I put a manhole in here that's 1.8 deep, and I've got 4 metres full across the site, then by the time that they build this house, and the drainage comes out at the lowest point there, it's going to end up a couple of metres below the manhole that we're trying to get into. So we have to come across and identify where the low points are on each of the sections, and then start to think our way through the design, the layout process for our pipe reticulation to make sure we can pick up those areas. So in that case, so this one can be, if this is the first one, it can be done model, you need to call it S blue opposite the next So you've already got one open. Do you Okay, so do you understand what I mean? We need to start to think about start to look at the layout once you've got that assignment open, or in this case our training data. You need to start to think about the most practical way of getting a pipe reticulation to the low point of each section.
Also, that whole thing is just figuring out where the low points are.
That's right. So in this case, if all the low points are in that bottom left-hand corner, say I have a pipe system coming down here, I'm going to want to send a branch up this boundary and pick those up, and I'm going to want to send a branch up this boundary and pick those up. Okay, so this way the pipe system is, I try and avoid having two lots of pipes in one person's yard. If that is a section, we try and avoid doing this. Okay, so that because two of his side boundaries are now restricted to construct things. So I would try and make sure that that one was over the next boundary. You just got to start to think about the most practical way that you can get a pipe system in to hit those low points. Sometimes, there's actually in some ways, the data set I've given you is a bit tricky. The scheme plan itself was designed by my boss, and he's allergic to straight lines. And instead of meeting at a common point, they'll all be offset. It's a right pain to wiggle things around, but it just means you've got to put a little bit more thought into it. Okay, so we're looking for the low points and how we can practically get to pick each of them up. The other thing is that you're trying to think about is the cost of putting the stuff into the ground is pretty prohibitive. So you're trying to do it not just in the most practical way to construct, but with the least pipe possible, so that you keep your costs down. Okay? Make sense? We'll have a bit of a to-do with it, and hopefully it will all come clear. Right, so what I'll do is I'll just quickly go through and set up our network editor for this line, and then we'll create another couple and we'll just see how the whole thing ties together, and we can start to put some rainfall data in. This is a particularly flat site. You can see there's a bit of grade up the top. This down here is particularly flat, and it probably is a real 50-50 as to which side of the lot. As I said, I've gone to the front boundary here just for the sake of drawing it up for this exercise. But once you start to muck around with it, it might work out that the most practical side is to take it up the back boundary. When it's dead flat, and you'll see when I get on to make a couple of extra stormwater lines, if it's dead flat, then the preference is to try and come up in the middle and pick the sections off either side, so you can do both of these. You understand, if it's pretty flat and the low point is, if we're not looking at a major difference from one side to the other, then the ideal is to serve all of those lots from one central line, so that you've got half the pipe, half the manholes. Okay, it's just going to come down to your judgment call. Right, so let me just restart this. Okay, so what we're going to do is I'm going to say for now I'm happy with what I've done here with my drainage line. Under the drainage edit toolbar I'm going to click save and finish. And from now on all the editing that I'm going to do until I start to shift manholes around will be within the network editor itself. Okay, so our drainage network editor is under our drainage toolbar on the very left hand side. We'll click on the icon for drainage network editor. And all I need to do is pick on my new line, anywhere on that line, and accept. And I'm now editing line 2. Has everyone got that? So I haven't done anything to my stormwater line except lay the manholes out, and now I'm going to go through and just set the defaults for my design.
How did you click the line, sorry?
Okay, so I just go drainage network editor. You can either click down on pick edit or it's already actually actively looking for it. So I just go to any point on my drainage line, pick and accept. Okay, just like last week when I do the setups, I work up on these top tabs. I start on the right and I work back to the left. And we start to actually manipulate the line. It's the opposite. We start on the left and work to the right. So the first thing I'm going to do is click on my global tab. Now I did set most of this last week. I know you all had to look over my shoulder, so I apologise for that. But I'll just run through it again. For the purpose of this course, I don't want to get into breaking down the catchments too carefully. Anywhere that the network editor prompts you for a percentage, set them all to 0.65. Okay? Just to keep it nice and simple. So if you look at the universal data here, we're in metric. We've set the finished surface already as tin ground. We're using the rational runoff method, and any value that it prompts within this network editor, we're going to set to 0.65.
Hang on, Steve. I can't move on to global until I pick my pit type.
Okay. I don't. For some reason, the defaults on this one are slightly different to. Sorry, bear with me. All it means is that you have to reselect one. Has anyone else got a warning under pit type? All it means is that the default setting that under the drainage defaults that is in there will be to concrete cover as a default. It's not in the drainage.4d file, so it's asking you to update it to a pit type that is. So if you just go into, say, a manhole 1050 or something like that. Okay, so all it's saying is it can't find that in its default list. Just before we move on, then I know you were having to look over my shoulder last week. Under here we have design, drainage, sewer, and defaults. This is where it's it might pay to set your defaults now, to reset them now, because obviously the .4d file is different from last week. And just make sure you pick off a, in fact, so we picked a manhole just MH last week. Under that pit drainage manhole defaults, just pick the type MH. The diameter is 1.05 and the drop is 50 mils. Okay. Under the pull down menu at the top, we've got design, drainage sewer, defaults. I'm just going to make sure we're just going to set the manholes and the pipes. So the manholes, 1.05, it's a 1050 manhole. The drop is 50 mils and the type is MH. And then we're going to go set and finish on that. And then just come back up again, design, drainage, sewer, defaults, pipes. Design, drainage, sewer, defaults, pipes. And pick class 2 pipe off the list. Okay, our default diameter is a 225, minimum grade is 100, minimum cover is 1 metre, and type is class 2. Yep.
These are your defaults, right? And your name as well.
No, so just get rid of name, just make it out, and under type, pick image. Okay, so by resetting those, then hopefully we won't pop up with any more errors on the background files not being compatible. Okay, so under the global tab, there it is there, metric, rational formula, and we've set our impervious is 0.65. Yep.
Just turns out like this is
Yep, this is just what we're talking about. What's happened is you've gone through and created your line with the defaults there didn't quite match because you guys couldn't follow through last week. So there you go. So now if you click on global, there we go. Okay, so that first one's pretty simple. Then utility models is our next tab along. Under global, utility models, we're going to start to set some of these now. Our catchment file, if you click on the little yellow folder, depending on where you've saved it to, that catchment.catchments was on Moodle. So wherever you've downloaded that from Moodle today. So once I've selected that, if need be, obviously you can. That's defaulted to. I've saved all mine in the same place as my project, why it's all automatically there. You may need to browse for it if you've saved it somewhere different. And what I can do is, if I open that, you'll see all it is it's asking me for a default polygons model that I'm going to draw my catchments into, okay? And it's going to look for, whenever it runs the network editor, it's going to look for polygons in that model and assume that they are the catchment. All we're doing is telling it where to look. Did everyone manage to find where they'd saved that? The labels model, we're going to create a model called catch label, so that once it's run this, it's automatically going to label our catchments for us. And under our label text style, which is a little greyed out box here, I'll click on the more information button, and I'm just going to pick off Arial 1 Center. It doesn't really matter what you pick there, it's just a text style. Okay? Happy? Okay, that's as far as we're going to go with this for this course. There are obviously these different, there's further options. We can set up a services clash so that we tell it that every time it runs the stormwater, it looks for the wastewater lines and makes sure it keeps the minimum clearance between them. Overland flow bypass is for if we have 68 litres per second flowing down a road. The first catch pit that flow comes to in the channel, obviously not all of it's going to make it into the pipe system, so we can nominate a model based on the curb profile, and we can calculate where that overland, the extra flow will carry on to, whether it can then drop into another pit later or whether it ends up as overland flow. Okay, they're all different things we can do, but we'll just try and keep it simple for this one. So as far as global goes, that's all we're going to do. We're just giving it a couple of utility models and we set the basic defaults. Okay, the next one across, up at the top, moving from right to left, is our defaults tab. As you can see, we can set defaults for the catchment pits and pipes. We're just going to work on one data set. Again, any time it asks you for an impervious, I want it set to 65% and make sure all the times of concentration are 10 minutes. So we get some kind of standardised response in the figures that come out at the end. Does everyone know what a time of concentration is? No? Yes? No? No? So if a drop of water lands at the furthest point from our pipe reticulation system, it's a nominal time to say this is how long it will take to trickle and get into the pipe system. Okay? So we've got all our times of concentration is 10, and all of our storm durations will be 10 minutes. Yep. You can do if you want to, but at this stage we're just filling out the defaults. Okay. So times of concentration need to be changed to 10 minutes, and make sure all our C factors and percentages are set at 65.
So if you set the TC to 10 minutes, what does that actually change in the pipe? Because wouldn't the time be dependent on the slope and the length of the pipe?
Yeah, it's
Does that change anything?
not really. I mean, all of them. I'm trying not to analyse too much, but no. But it's a fair enough question. What you'd normally do is you would have to analyse and try and work out those times of concentration, but just to keep it standardised so that we get a basic response, so that the figures that come out at the end have some kind of standardisation, we'll just keep to a blanket assumption. Okay. Okay, so the next under the defaults, that's the catchment. Next we're going to click on our defaults pits, the middle tab. Okay, again a lot of this is already filled out. We'll keep our KU factor, which is our head loss through the manhole, at 2, so it's nice and conservative. And we just want to make sure that our set out data has the set out XY mode as the pit centre, the set out Z mode is the cover RL, and the road change, we're ignoring the road data at the moment, okay? Finally, under the defaults then we have pipes. And this is pretty important, okay? Our roughness type is Colebrook with a roughness of 1.5 mils. Okay, 99.9% of the council standards will require to use a Colebrook size pipes. 1.5 we use up to any pipe up to 1 metre in diameter. We use 1.5, and after that it changes to 0.6. Our invert design, we're going for the grade mode is minimum depth, and remember that the alignment mode is obvert to obvert level drop, so that if we are dropping from a smaller pipe to a bigger, I hope I explained that properly last week. This is the invert level, this is the obvert level. Okay, invert, obvert. Sometimes it's, they refer to it as the soffit of the pipe, but we just use obvert. One of the most important things to set is the design mode. Make sure that that is not on pressurised, okay? It defaults to pressurised pipe freeboard design. We want part full pipe freeboard design. It'll come out with some pretty interesting figures and pipe sizes if you pick pressurised. We'll leave the freeboard limit at 0.3 and our flow depth limit at 100. Is everyone happy with the defaults to enter for? Okay. Yep. Okay, so that is the global and defaults, and just remember that the next three tabs here, anything that we've entered into our global or defaults can be overwritten under these next three tabs. Depending on which one we've got highlighted, we can change the values or design criteria for either pipe, pit or catchment. Right, so we're going to head down to the, we're just going to start to run some basic, all we've done is enter into the values so far. We're now going to start to run some information through and apply these to our drainage stream. Okay, as I said last week, if you look at this in section, we've got a cyan line here, that's our hydraulic grade line. Obviously it doesn't know how much rainfall is going in yet, so it's done nothing. It hasn't come up with any kind of solution for the grades or whatever, so now we're just going to start to put the information in. Okay, the first thing we do, the stuff on the top was right to left, this is now left to right. You've got to do set pit names before anything else. I'm going to click on set pit names and run. Okay, it tells me that pits and pipes have been named successfully, and I'll click back to the editor. Okay, I'll do that again for you. Set pit names, run, back to the editor. You can now see if I click on that pipe tab at the top, it tells me that it's editing between manhole 2.7 and 2.6. Okay, it's now picking up all the pipe sizes, diameters, lengths, etc., etc. Now I don't have any catchments in here, we'll get onto those in a second. So I'm going to come across, I'm going to click set pit details. And I'm going to click on regrade pipes. So now if you have a look at my long section, in section view, everything is evened itself out so that it's trying to follow all of those basic criteria that I've given it. It's graded things so that nothing's flatter than 1%, because that's the minimum that's that it defaults to. Okay, and now all of the incoming inverts are at least the same level, if not higher than the outgoing.
Did you do that again?
Yep, sure, no problems at all. So all I've done is move from left to right set pit names. I don't have any catchment details yet, so I haven't bothered to press that. I've clicked set pit details and I've clicked regrade pipes. Okay, I've just moved from left to right. Right. Just has everyone got that far?
I'm just wondering, grab.
That's it. You turn the tin on.
When you gonna send it? Send it?
It's looking for tin ground to kind of want it to live. What you've done is when you create tin ground name all I would do is
design.